5, 4, 3, 2, and 1. Alright, today's where it starts to get fun. Today's where it's cool. Alright, did y'all take a look at my triangles yet? Some of y'all, I know, finished the warm-up and started looking already. Started thinking about it. So how many dark triangles will appear in the next figure? We got 1, and then we have 3. You already counted that one up? 9.
27.
So can you see what's happening?
81. They multiply each number that they keep from the last figure by 3.
Within each triangle, we're just subdividing it. And you can keep subdividing it. Let me use a different color here. And good, someone already noticed a pattern I heard, I think.
81.
So how'd you get 81?
27 times 3. Everything times 3.
So every step. Notice, what have we been doing? Monday, Tuesday, Wednesday. Have we done any multiplication? It's always been what? Add or subtract. So today, when I talk about geometric sequences, now I'm talking about multiplication. 57. I don't know how you got 57. Figure 7. Let's find out. What did you do?
What?
Okay, so we've got figure 5 had 81 triangles. Figure 6 has I think we skipped one.
81 times 243. And 7. 729. 2,180. So 8.
So figure 8. Now you already know where this is going. What if I ask you which figure has 893,527,411 triangles?
And we gotta do
Yes, there's a equation or a formula. I'm not going to make you write down a million little times 3, times 3, times 3. But hold on, before we go on, how did you get times 3?
just looking at it. I just looked at it. Look, those small triangles.
But will you always be able to can we systemize it a little bit? Can we make it more systematic? How could you look at, for example, 27 and 9? How could you look at them and say, okay, times 3?
You divide 27 by 3 and get 9 and multiply.
Not quite. Let me tell you, and you might want to write this down, because this is going to be very important. Pick a term and divide it by the previous term. So 27 divided by 9 would give you times 3. So when I look at these other ones down here, when I look at this one, I'm going to do negative 72 divided by negative 12. And that will give me my common ratio. Now it's not a common difference, it's a common ratio. Okay, so let's write down our formula and then let's try number 3. And the formula looks like this. The nth term, or the last term, because when the terms are fractions, you're not going to be able to just look at it and tell. You're going to need a system. So pick a term and divide it by the previous term, the one in front of it. The nth term is equal to the first term times r. So there's no d in this problem. This problem has r, which is
R is D.
instead of the common difference, now I'm talking about the common ratio, because the key difference in these problems is I'm not subtracting 2 each step. I'm not adding 7 each step. I'm multiplying by something every single step. And then this problem has an exponent in it. So you're going to use the rooftop or the exponent button on your calculator. And you finishes off with to the n minus 1. And n, of course, is the number of terms. Okay. And I've already added it to the board. Do you have to memorize any of these formulas? You don't have to memorize a single one. They're all going to be in the book. Yep. Log on.
What's the expertise?
What?
Addition.
Let's talk about that. I've put a little note. This is not an X and a T. This is an addition sign and a multiplication sign. So you know it's what's coming. There's going to be a worksheet. It's going to have both of these on them, but I'm not going to tell you. I'm just going to give you a pattern. I'm going to say, find the 50th term. Or I'm going to say, find the sum of the first 729 terms. And you're going to have to decide, which one do I use? Do I go this route? Do I go the arithmetic route? Or do I go the geometric route? You have to look at the pattern and decide, are we adding 2 each time? Or is this multiplying by negative 1/4? Okay, so there are some tricks. I'm going to teach you a couple tricks, and then let's practice. So look at this problem here. Lisa deposited some money into her account at the beginning of year 1, which is compounded annually. The table to the right. Have I ever showed y'all how to get rich slowly?
Oh, yes, you add the dollar. No.
Did we do the investing calculator? Okay. Yep. So that when you're 60, you can drive a Lamborghini if you want to.
Oh.
Yeah. Okay. Good. And you'll be able to pay for your grandkids' college. Wouldn't that be nice if you could go to college for free? It didn't matter how much it cost?
Yep.
That'd be great. You didn't have to think about that. Let's do that for let's make sure that our grandkids don't have to worry about that. One day you are going to be a grandma. Think about it. You gotta take care of that too. Okay, the table to the right is the amount. How much will she have after year 12? So, first thing is this. What's the common ratio? Or is this a common difference? Is it a difference or a ratio? But how would you know? So look, if you tried to add each time, look, you would add 10, right? But then
That would have been added 10.5.
and then it would be adding 10.50 or 1050. So you know it's not arithmetic, this is geometric. So we have to find the common ratio. Yes. So you do 210 divided by 200. Or you,
say 1.05.
or you could have done 220.5 divided by 210. Guess what? Get the same thing.
What's that? Okay.
So I don't care if you do the red or the blue ratio, you're both of them are going to get 1.05. Is everyone able to figure that out? See that? Both of them give you 1.05. So it doesn't matter which one you use. Just pick one and divide it by the previous number. All right, we have our ratio. We also need, for this formula, the only other thing we need is the first term. And what's the first term here? 200. Okay, so let's start off by writing. A lot of you are struggling with this vocabulary too. Start off by writing the explicit formula, which means you leave n in the problem. So let's say the nth term equals. Right, we're going to leave n in the problem first. That's called the explicit formula. So on these problems where it says write the explicit formula, this is what you do. Now, let's go ahead and solve. Which term do we want? The 12th term. Is she going to make any money by the time year 12 comes? Not about how fast you go. Well, what's the unit? Is it cows or miles or hot dogs or what is it? Is
I
it
do the $12.
dollars? So
Do the kick. Kick from the thing. No, go there.
This
Oh, next to no. The little arrow looking thing. Next to the explain.
do we need some help typing this into the calculator?
Yeah.
I ain't gotta push the trunk.
Okay.
Okay.
200 parentheses 1.05. Use your exponent button, and you can just put 12 minus 1. You could put 11. That'll be a little bit faster if you want to. So $342 and how many cents? No, 7 cents. Write them carefully. So she made some money. Lorian.
My calculator, when I put 275 by 200, give me a fraction. Instead of constant fraction, just pick up. So okay, automatically.
You probably could use a ratio as a fraction, but you can try that if you want to. I guess I don't really have any reason for you not to do that. I mean, menu 2.1 isn't that hard, is it? Menu 2.1, just real quick, convert to a decimal. Okay. Let's do one more together, and then I'll let you work. Look at number 10. And 10 has a dead giveaway.
Something wrong with JD?
Y'all must not have seen that video, huh?
What video?
Dead giveaway.
No.
I can't believe y'all haven't seen that. Let's see. Number 10. The dead giveaway is that it goes from negative, positive, negative, positive. So there's no way, listen carefully now, I need you to listen and not write. Don't try to do the problem, listen. In real life, you're not going to know right from the start if it's a common difference or common ratio. That's the hardest part of these. So what I want you to think about is, look, if we tried to do a difference from negative 3 to 9, that's plus 12, right? Do I add 12 to get the next number? No, if you try to do that, you're going to get 21, but the next number is negative 27. So that's how we check. So then you say, okay, it must be geometric, which means you have a common ratio. So then you can try our trick for that, which is 81 divided by negative 27, which would give you R equals negative 3. Right, this is not a D, this is not a common difference. Right, this is a common ratio, times 3 every time, times negative 3 every time. And just to double check, does that work on the next one?
Yes.
Yeah, negative 27 divided by negative 3. Okay. Once we find the ratio, what else do we need? First term, negative 3 also. Is it always going to be the same?
No.
This is a freak occurrence. Okay, this is a freak, it's really weird, these are the same. So don't get used to that. Okay, so let's write the explicit formula. The nth term is equal to the first term times common ratio, right? Minus 1. All right, now we can substitute in. So we want which term? The 11th term. And when you do that, type it in. Now think about it. Before we were just adding 7 every time. But now if I multiply, that gives me a lot bigger chance to get bigger numbers. Because I'm taking a big step every time. If I multiply by 3 every time, 1 times 3 is 3. Times 3 is 9. Times 3 is 27. Times 3 is 81. 243, 729. Suddenly the numbers start getting really big, really fast. So you got to think about that. That's why some of these answers are going to be huge. This one's not even that big, really. What if I asked you for the 29th term here? Do up, up, enter on your calculator. If I asked you for the 29th term, so you're going to put, for the exponent, you're going to put 28. Okay, so think about it. You're just multiplying by 3 every time. I mean, it's going to get huge, yeah.
How 4 through 7 we don't solve it out, we just find the ratio.
4 through 7, you just set up the explicit formula. You do this right here. And then you got the back, which is more of the same.
I know.
All right, so we're going to do sequences today. We'll probably do series tomorrow. I don't remember if I see y'all tomorrow. I have to double check the schedule. I think you're right. I think it's 4, 6, 7, 5. Yeah, it's a weird schedule. Okay.
We gotta go to who first, Steve? It's crazy.